WST stuff, but there's also some more exciting news. We've spotted. I mean, I feel like people like to think that we've learned everything we possibly can about our solar system, but we actually definitely not true. And we actually just found new moons around Uranus and Neptune, which is pretty cool. So
That
like
is unbelievable. How were they found? Do you know with which instrument?
so it was a Carnegie astronomer. The instrument was it was made
Scott
in
Shepherd.
it was Scott Shepherd. How did you
I
know
know,
that?
yeah, I know Scott Shepherd. Yeah, I've done some work with him. He's a really amazing moon and asteroid guy.
What a legend! Look at this guy. It's like, oh my
Yeah,
god, we.
yeah,
Oh my god, you're a freaking legend, man. So, did you work with Scott Shepherd on anything or?
yeah. I've done some observing with him a wee while ago, but yeah, very. I did some rotation period work of asteroids, the Trojans around Jupiter. But Scott's been is I can't remember. He works often with a companion. I can't remember his name now. But yeah, no, Scott does some amazing work in solar system dynamics, discovery of new objects, moons, that kind of thing. Yeah.
That's super cool. It's so cool that you like. Oh man, I get pretty excited when I get to tell people that I know you. So I can kind of like that.
Who?
That's my biggest claim to fame. I know David James,
That's a pretty small claim right there.
not the Olympic athlete.
It's
But
actually,
yes, sir.
sorry, there's a goalkeeper in football in British soccer who used to play, who's called David James. Well, he still is called David James.
What there's an Olympic athlete named Michael Johnson who is my old supervisor for those that don't know at
Yeah, right.
Harvard. And when I first joined his group, before I met him, I did a Google search and was very confused for a while.
Given that he
I
was
was
the
like,
fastest man on Earth for 10 years.
yeah, and then he switched to physics.
I know. Well,
Like,
he
whoa.
was just as fast as an electron, that guy. Holy cow,
I
could
was
he?
like, yeah, Olympic athlete and star physicist. His parents
Yeah,
must be
that's right.
very proud.
He had a
um,
beautiful upright running style. He used to be so rigid from the hips up, but he was so fast. Oh, I loved watching
Are
him.
we talking about the same Michael Johnson here? Because uh, I my height terminates at our Michael Johnson's like midriff. So I mean, I have no information about the rigidity of his upper body.
Yeah, he's about my height. He's about 6'3", 6'4". He's a big
He's
boy.
which Michael Johnson?
The astronomer.
I think he's taller actually.
Yeah, he might be an inch or two
I
taller
think
than
he's
me.
like sick. He might be sick. Like I mean, he was.
He
I
might
used to
be
say like
six five, six.
I just for the record, if Michael ever sees this, I loved being Michael's student, and I hope to again someday. But I used to joke that the toughest part about being Michael's student was that you're always looking up to him.
Oh, very nice.
In both ways.
Yeah.
But anyway,
Yeah.
to answer your question though, so the discovery was made using observatories in Hawaii and Chile. I'm not sure which ones they were, but the follow up observations were done with the Magellan telescopes, which I
Uh,
think are in Hawaii.
so no, so Magellan is in Chile. It's
Oh, it's in Chile.
the Barde and the Clay telescope, 6.5 meters. Um,
Okay.
yeah, so that's why you need them because of course these are super faint. So he was
Mhm.
probably doing dynamical imaging, as in watching them, move. So I
Okay.
suspect he may
Oh,
have been.
actually, no. So I did some research into the method. It wasn't dynamical imaging because I was curious about that. Like I was like, I'm always interested in stuff because it's like adaptive like speckle optics or anything. It's so what they did was they did this technique where, and I don't understand this actually, so maybe you can help me out. But the way they say the technique works is they move the camera at the same rate as the planetary system. So all the
Yeah.
stars and stuff
Yes.
appear fixed, but the the planet and its moons don't. But I actually didn't understand. Sorry, all the stars and stuff appear like trails, but the
Yes.
moons and stuff don't. And I actually
That's,
included a picture of this on the blog.
yep.
And by the
Yep.
way, the blog has now passed 11,000 views thanks to our amazing viewers. So keep following us
Congratulations.
for preview on the stories that we'll be talking
Yeah,
about.
that's right. So this is sort of inverse dynamical imaging. So normally with dynamical imaging, what you do is you take a series of photos or images with a telescope, and then you look for things that move. That would be something like a planet or meteors or asteroids. In this case, what they've done is they've done non-sidereal tracking, which means they're not following the rotation rate of the Earth. They're following the rotation rate of Uranus or Venus, which Uranus this is. So this is Uranus right here, not the yellow arrow. The yellow arrow is pointing to the moon. The bright object is Uranus, and
Not this
all
thing, this thing on the left.
Oh, yes, you're quite right. Sorry, thank you. Yep, you're
Yeah.
quite right. So that's it on the left. And then you're seeing these streaks because, of course, Uranus is moving against the background of stars because it's a solar system object. But if you set the tracking rate of the telescope to Uranus, anything that moves with Uranus, as long as it's not the moons aren't orbiting really quickly, like the Galilean moons, for instance, will not be streaked because they are co-moving with the planet.
So that's actually what I was wondering. That's actually what I was wondering. I feel like the is maybe why are the orbits so slow? I guess is what I'm wondering. Like, I
Well,
guess. Oh, I see. I maybe this is because this technique only works on. It's like self-selecting for slow orbits because both of these orbits are slow. One of them is a 27
yeah,
year orbit,
27. There you
and
go.
one of
That's right.
the other one on Uranus is 680 days.
Yeah.
Okay.
Yes, that's right. So the orbital period is so slow that to even say a 1 hour exposure, they don't appear to move, especially relative to the background stars.
Okay.
In fact, yeah, I mentioned that Scott often works with a colleague. Here it is. It's Chad Trujillo. Yeah, that's right. And
Yep.
so, yeah, this is inverse dynamical imaging. And so the reason why the dot at the end of the yellow arrow, which is one of the new moons, appears to be static, is because it's co-moving with the Uranian system as it orbits the sun. Even though, of course, it itself is moving, if it's a very long period object, like has a period of years, in a 1 hour exposure, it doesn't appear to move.
Okay. That's unbelievably cool.
Yeah, it's
Uh,
amazing. Yeah.
and it was. I mean, the this moon is just 5 miles wide.
Wow, it's amazing.
Like, it's kind of unreal to think that like you're able to see an object 5 miles wide at the distance of Uranus.
Yeah, absolutely. Well, given that Uranus is obviously physically very big, much bigger than the Earth, it begs the question whether it's a real co-produced moon or whether it's a captured meteor.
Because you're getting more Kuiper belt objects out there at that distance. So not too many at Uranus distance, but like you're gonna have some free floating rocks.
Oh yeah,
Um,
absolutely. I mean,
so
if it's 5 miles across, 8 kilometers across, it's essentially a pebble.
yeah, it literally is.
I
Yeah,
mean, seriously, it really is compared to the size of Uranus itself. I mean, even
that could
compared to the
that could potentially, if you're right and it's a captured object, that could be a next, like, because the Ultima Thule mission, they renamed it, but I don't remember what the new name is. Arakoth or something. Um, I forget what it is, but the New Horizons mission, when they went to Ultima Thule, that helped answer a lot of questions about the pebble accretion process and the formation of the solar system because Ultima Thule was so old and so well preserved. If this is a captured moon, which I honestly I bet it is, given how small it is and how far away it is from Uranus, if it is a captured moon, this could be a much easier target than trying to pin something in the Kuiper belt down because we know the period now. We have pretty much exact astrometric coordinates as soon as it's observed and with the follow up observations. So that could be a really interesting target for a future mission.
Yeah, that's right. That's right. Yeah. Although, I suppose so. It depends what you'd want to find out about it. Because I mean, what just because it's captured, perhaps the real interesting thing would be its chemical composition, whether it had processed or reprocessed material on the surface.
Well, and not just the chemical composition, but like for example, with Ultima Thule, it had quite an unusual shape because it was basically two
Mm.
pebbles stuck together.
Yeah, that's right.
And that was a big, validator for the pebble accretion hypothesis. And
Mhm.
then there wasn't just the chemical composition. The fact that it was tumbling was, I think, an important indicator of something. That was really interesting. And even just the chemical composition, having access to the chemical composition of an object that may have been effectively untouched since the beginning of the solar system is it's like a time machine, basically.
That's true. I mean, pristine material. There's probably millions of those types of object, even in the asteroid belt. So I
Oh,
don't know if
there's,
we.
I mean, I think literally probably, well, I don't know what the estimate was for like Kuiper belt objects, but the problem is with the asteroid belt, it's hard to distinguish the new material from
That's right.
old material. Yeah.
That's right.
Uh, but I love this kind of stuff though, because it really, like, there's so much we don't know about our own solar system yet and
I
stuff
know.
like this.
True.
And this technique is incredibly cool too. I remember you'd be surprised. You could see Uranus with not too big of a telescope, but I still remember the first time I saw Uranus through the 6 inch. Um, oh my God, that was like almost a that was like a momentous first view. Like it felt to me almost like seeing the Galilean moons for the first time. I think it was less life changing because the seeing the Galilean moons for the first time was one of the things that set me on like the astronomer path. But like it felt as crazy, like because I felt like coming into that, looking at Uranus, knowing how far away it was, knowing the math, knowing the size, and you can tell, you can tell it's not a star.
Yes.
You can tell it doesn't look like it. That was it was just one of the most. I'll never forget that moment. The first time I saw Uranus through a telescope was unbelievable.
Yeah, I couldn't agree more. I've always liked Uranus. I think we did this when we did our favorite planets on one of the earlier coast to
Yeah,
coasts. Is that I just love the fact that it's got a very faint ring system. It's still got this beautiful deep blue sort of greenish hue because it's a all the methane is absorbing the infrared, the redder light, sorry, and the fact it's tilted on its side, it looks as though it's been hit like a bowling ball hitting skittles.
it's such a weirdo.
I know it's amazing actually. Yeah.
It's a great planet. It's easily top 10 planet in the solar system.
Oh, easily.
Easily.
Well, probably down the top nine now, maybe top eight.
Yeah, exactly. It's one of the top 50 major planets in the solar system.
Of all the planets we know in the solar system, it's one of our favorites.
Of all the planets I've ever seen, Uranus is one of them.
Amazing.